Hello, welcome to Math with Mr. Dobrescu. To the rescue, let's take a look at a couple of warm-up problems here for today. We have 5 to the second power times 5 to the 7th power. By the product of powers property, we know that if we multiply two exponents with the same base, we keep the base, which is 5, and in this case, we add the exponents. So it would be 2 plus 7. So the answer would be 5 to the power of 9. Let's take a look at the second example. In this example here, we are going to use the power of a power property. Based on that property, we keep the base, which is 3, and in this case, we are going to multiply the exponents. So it's going to be 4 times 7, and we know that 4 times 7 is 28. So the answer is 3 to the power of 28. In example 3 here, we are going to use the power of a product property. Based on that property, if we have 6 times 8 in a parenthesis, all to the power of 3, each of these bases is going to be raised to the power of 3. So the answer is going to be 6 to the power of 3, 8 to the power of 3. So both of these bases are going to be raised to the power of 3. And finally, for example 4, we are going to use two properties here. First is going to be just like example 1 here. We keep the base, which is 3. And in this case, we are going to add the exponents first. We have 2 plus 6 divided by 3 to the 8. And now we know that 2 plus 6 is 8. So now we have 3 to the 8 divided by 3 to the 8. And finally, now we are going to use the quotient of a power property, right? So based on that property, we keep the base, which is 3, and then we subtract the exponents, 8 minus 8, and this will be equal to 3 to the power of 0. And today we are going to discover that any number raised to the power of 0 is going to be 1, except 0, because 0 to the power of 0 is still 0. But remember, today we are going to learn that any number raised to the power of 0 is going to be 1. Because remember, 3 to the 8 divided by 3 to the 8, if we multiply 3 8 times divided by 3 8 times, it's going to simplify to a 1. Keep that in mind as we look through the lesson today. Let's take a look at our lesson today, 0 and negative exponents. So today we are going to look at the first activity. We are going to use the quotient of a power property. So based on the quotient of a power property, if we have 5 to the power of 3 divided by 5 to the power of 3, we keep the base, which is 5, and we subtract the exponents. 3 minus 3, and that's going to be 5 to the power of 0. Okay? So the power form is 5 to the power of 0. And also, if we use the extended form, remember, 5 to the third power means 5 times 5 times 5, and the same thing on the bottom, 5 to the third power means 5 times 5 times 5. Sorry, that's a 5. And now, we can simplify. We can simplify 1 5 from the top, 1 from the bottom, another 1, and another 1, and all this is going to simplify to a 1. So remember, you see that 5 to the 0 also means a 1. So they are equal to each other. 1 or 5 to the 0 is the same thing. Let's take a look at the other example, example 2 here. The same thing. We keep the base, which is 6, and we subtract the exponents based on this property, quotient of a power property. So let's subtract the exponents, 2 minus 2, and here we get 6 to the power of 0. And again, if we do the extended form, 6 to the second power means 6 times 6. And on the bottom, the same thing, 6 times 6. And if we simplify that, simplifies to a 1. So remember, the power form is 6 to the power of 0. And again, 6 to the power of 0 equals also 1. And as you discover the other two examples, I want you to do the other two examples on your own and find out if you also get negative 3 to the power of 0 and negative 4 to the power of 0, and if you also get a 1. Pause the video, do those two examples, and then let's come up with a general rule. Okay, any number raised to the power of 0 except 0 should equal 1. Okay, please keep that in mind. Very, very important rule in mathematics. Any number except 0 raised to the power of 0 is 1. Remember that. Okay, let's continue. In this activity, activity 2, we are going to use the product of powers property. Okay, and based on that property, based on the product of powers property, we keep the same base. If we have the same basis here, which is 3, we keep the base, and in this case, we are going to add the exponents. 0 plus 4, and 0 plus 4 is still 4. So we end up 3 to the power of 4. So the power of 4 is 3 to the power of 4. Let's take a look what happened here, right? So here, if we get 3 to the power of 4, which is the second number raised to the power of 4 here, it means that 3 to the power of 0 must be 1. So it means 3 to the power of 0 must be equal to 1, right? Because we just learned it in this activity, right? Any number to the power of 0 equals 1. So here, any number to the power of 0 equals 1, which it tells us again that any number to the power of 0 equals 1. It gives us another example for you to understand that to get any number raised to the power of 0 except 0 equals 1. Let's take a look at the second example here. The same thing, we have a to the second times a to the 0. Okay, based on product of powers property, we keep the base, which is 8, and then add the exponents. 2 plus 0, and here we get again a to the power of 2. And again, a to the power of 0 must be 1. A to the power of 0 must be 1, right? And here we get a to the power of 2. So again, any number raised to the power of 0 must be 1. So again, 3 to the power of 0 must be 1. Okay, keep that in mind. Again, that any number raised to the power of 0 equals 1. And please pause the video and you can finish the other two examples and you should come to the same conclusion. Let's take a look at our last example here. Activity 3, using the product of powers property. So based on the product of powers property, the same thing here. If we keep the base, which is 5, and in this case, we are going to add the exponents. Negative 3 plus 3, and again, we get 5 to the power of 0. Again, 5 to the power of 0. But let's take a look at another aspect here. What do you think would happen? What happened here if we multiply 5 to the power of 3? So if we multiply 5 to the power of 3 by its reciprocal, what do you think is the reciprocal of 5 to the power of 3? Okay, the reciprocal would be 1 over 5 to the power of 3 times 1 over 5 to the power of 3. That's the reciprocal of 5 to the power of 3. So if we switch 5 to the negative, if we replace 5 to the negative 3 by its reciprocal, 1 over 5 to the power of 3, here we get, now we are going to get 5 to the 3 over 5 to the 3. If we multiply this together, and if we use that rule, the quotient of a product power property, we get 5 to the power of 0, okay? And 5 to the power of 0 is also equals 1. Okay, so again here we use the reciprocal of 5 over 3, which is 1 over 5 over 3. Let's do the same thing for example 2 here. 6 to the power of 2 times 6 to the negative 2. Again, the base is 6. We add the exponents, 2 plus negative 2. And here we get, again, 6 to the power of 0. So 6 to the power of 0. And again, if we multiply 6 to the power of 2 by its reciprocal, so here if you multiply 6 to the power of 2 times the reciprocal of 6 to the power of 2 over 6 to the negative 2, okay, the reciprocal of 6 to the negative 2 is going to be 1 over 6 to the power of 2, right? It's reciprocal. Again, here we get 6 to the 2 over 6 to the 2. And if we simplify that, we get 6 to the power of 2 minus 2, which is equals to 6 to the power of 0. Okay? So in general terms, after we finish the other two examples, we can say that the product of a number and its reciprocal is 1. So the product of a number and its reciprocal should equal 6 to the power of 0 or 1. Okay? And if we have any base raised to a negative exponent, must be equal to 1 over a to the power of n. The reciprocal of a to the negative n is going to be 1 over a to the n. And if we see some of these problems in future examples, if we see any base raised to a negative exponent, we are going to turn this into 1 over a to the power of n, or the base to a positive exponent. Please keep that in mind. We are going to do more examples on that. If you are a little confused on that, we'll do more examples. And until next video, please don't forget to like and subscribe. And I'll see you in the next video. Take care.